Hi, welcome in this video of our series on the data loading tools. Today we will explore some more advanced methods for mapping your source and target data models using the data loading tools. If you haven't had a chance to view our previous videos, visit our GeoNet page for more resources and links. Also, are you familiar with the latest update of the tools? Some new data mapping capabilities were added, including predictive field matching options and predefined mapping. To learn more about what's new in this update, check out the video. Now, in today's video, we will look at how you can use inline expressions and external functions to further streamline some of your data transformation process. Then we will take a closer look at the mapping of data models which are supporting subtypes. So for this demonstration, I've generated a few different data loading workspaces, so I can show different ways you can apply these capabilities. I will first demonstrate the capabilities using data models I've created for the purpose of this video, and will then compare it using a real-world example. So here's my project with a source layer and a target layer, and I would like to load the data from my source into my target data model. The data itself is a series of lines on the map, as you can see, forming the words data loading tools. To do this, I've created this data loading workspace, and I will use this workbook to define the expressions that will transform the data when I execute the data load. So first, let's take a look at inline expressions. Inline expressions can be used to further customize your data loading. These expressions should be written in the expressions column of the data mapping sheet. You can use a wide variety of Python functions when you write in this column. Excel functions are not supported in these workbooks. The execute data load tool you run when you are ready to load your data from your source to your target will read the content displayed in the cell rather than any Excel function you may have used. So another way to see this is that the expressions you write here would need to be valid in the Calculate Fields geoprocessing tool in ArcGIS Pro. So for example, in my workbook here, I have this target field named uppercase, and I would like to load the data from the source field named lowercase, and transform the strings to be uppercase when they are loaded into the target field. So if I enter the Excel function upper in front of the source field, then Excel displays this as lowercase in the cell. And this will not actually transform the strings from my source field to uppercase. This will actually only load the values from the source field into the target field without any transformation. So if I need the values from the source field to be transformed to uppercase when loaded into my target field, I will need to use the Python expression with the Python function. So as you can see, I'm actually using one of the Python functions available in the tool here. So now let's take a look at some more examples of inline expressions you can use in your workbooks for simple manipulations similar to the one we just did. Other text manipulations like uppercase can also be performed. For example, I could add letters to an existing string, or simply generate a new string on data load if needed. Here I could add the prefix a to the value in the lowercase field when it's loaded into my target field. So let's take this example into context. In this project, I want to transform my address points data when loading it into a new data model. As you can see here, the field full address in my source layer is all lowercase. I would like to load this field as uppercase into my target field full address, and also add the region name at the end of the string. In my workbook, I find my target field full address and add the upper function against the full address source field. I will also add the string New Zealand. Now let's run a quick data load to view the results of this transformation. As you can see in the loaded data, the field was properly loaded and is now all capitalized and includes the additional New Zealand string. Now let's go back to the demo project. I can also use an inline expression in the workbook to quickly and easily concatenate values from 2 or more fields into one single target field. So here in the concatenate one target string field, I would like to concatenate a few fields just to see what happens. Let's try to concatenate the following source fields: the length, which is of type double, the date field, and a simple string like the name field. The expression could be as follows. And if I run this as it is, I will see all my values are now concatenated in the target field. Let's go back to the addresses project and see how this could be used here. So for this case, let's say I don't have a full address information spelled out into one single field in my source data set. I would need to reconstruct a full address based on a series of different fields. So here, if I take a look at the available fields in my source layer, I could use the following fields to reconstruct the address: full address number, full road name, suburb locality, and town city. In my workbook, it could look like follows. With the address number first and a space, and then use a join function that splits every value with a comma. And if I still want it to be uppercase, I can add the upper function. And I can still add New Zealand at the end if I want to. So let's run this and review the results. So as expected, the full address was loaded into my target field. So now let's take a look at the opposite of concatenate and split values from the source when writing them into the target. So for example, I may have a string in the source field, which I would like to split into 3 separate target fields. And the string is being split where there's a space or some character. So in my project here, if the values in the source field are as follows, I would use the following expression to split these values into 3 separate target fields. So for the split first target field, I will use the split me source field and the split function with the hyphen as a separator, and 0 for the position of the first value in the string. So same thing for the second field, split mid, but here we want the second value in the string. And finally, for the last value, we can use 2 to indicate that this is the third value in the string, or -1 to actually extract what is the last value in the string. So if we take this back into the context of the addresses, I could go ahead and do the opposite of what we've just done with the concatenate example previously. So let's ignore the fact that I already have the values split up in other fields. And just for this example, let's use the full address source field to try and split it up into separate target fields. So for the full address number field, I type in the expression, and I will use a space to split my values in this case, and use the 0 to grab the first value. For the full road name, it will be similar, although I grab the second and the third values. So I need to first split at the comma and grab the address number and street name, and then split at the space to keep only the street name. The suburb name can be added to the municipality target field. And I'm done here since there's no additional field for storing the city name in the target data model. So I can run the execute data load and review the results for this scenario. Now for simple calculations, I could for example convert values from one unit to another. If the values in the length field are defined in meters, I can convert these values to feet using the following expression. The length meters field times 3.28, where the length meters field is the length in meters of one of the lines in my source data set, and 3.28 is the number of feet in 1 meter. To take this into context, let's take a look at another example. So here we're looking at data from a stormwater network. I'm loading data from an older data model into a more recent schema that supports the utility network. In the source dataset stormwater gravity main, the measured length field is calculated in feet. So let's transform this value to meters when we load it into our target dataset. In the workbook, I can see a lot of fields are already matched. The target field I'm looking for is measured length, and the expression should be a division this time. Now, if I execute the data load for this dataset, I will get the new measured value in meters in my target dataset. Finally, let's take a quick look at the date object in an inline expression. To extract the year, month, or day from a date value, I will use a function against the source field. To get the day value in my day target field here, I will type date.day. And when I execute this, I will get the day value in my target field. We will see how we can do more with dates with external functions in the next section. Now, all of the inline expressions I've added to my workbooks are specific to the fields in these workbooks. If I want to reuse some of these functions in other workbooks, I can instead add them to a Python file and then reference them in the workbooks. External functions can be used to further streamline some of your data transformation process and will allow for more advanced and multi-line functions. The scripts folder in the data loading workspace already contains Python script examples of common functions that can be applied in the mapping workbooks when executing the data load. You can write your own Python functions and either add them to the existing base Python file or create a new Python file and call them through your data mapping workbooks. The execute data load tool will run through the scripts folder and look for the functions you've added. First, here are a few functions that are already provided with the tools. So we have create grid, concatenate, and year to date. Let's quickly review how you can use these. In my workbook, I will add the create grid function against the global ID target field. This will automatically generate a global ID value for all my features when they're loaded into the target feature class. So this one's really simple, so I won't execute the data load just now, and let's take a look at the concatenate function instead. This one will require more input from your end. You need to specify which fields you would like to concatenate and define the delimiter between these values, such as a space or a hyphen, for example. So in my demo workbook, I will concatenate the field's name, year, and date, and use a space separator. Now if I execute the data load, the concatenate to target field is populated with these values, along with the grid we defined earlier. If we go back to the addresses example, I would like to concatenate the address number, the road name, the suburb, and the city to get the full address in my target field. And I would like for these values to be separated by a space. And if I execute the data load, this information is loaded successfully in my target field. Finally, there's one more function provided in the base Python file, which is the year-to-date function. This one is meant to help you convert a year value to a full date value. If you only have the date value in an integer or short number source field, you can load it into a date target field using the existing year values and defined month and day values. So here I will use a year value field and add 1 and 1 for the 1st of January of that year. As you can see, when I execute the data load, the source year is used to populate the new date value. I can change the month and day values as I like and execute the data load again. So now let's see how you can also create your own functions. So in the data loading workspace folder generated in my demo project, in the base Python file, after the existing functions here, I will add a new one and name it extract numbers. I want to extract numbers from the values in a string field to load them into an integer field. For this text manipulation function, I am basically cleaning up a field that has a mix of letters and numbers and extracting the numbers from the string. If there are no numbers available in the string, I will return a value of -1. So now I can also apply this function for the address number field in my address example. So I add the function to the base file and call it in the appropriate workbook. And now if I execute the data load, here are my integer values. So next, for another custom example, I would like to define the values for my target field based on existing values in my source fields. So for example, in my stormwater data here, the pipe material and the install date information are provided in the source data, but no information is provided for the liner method. But I like to populate the target liner method field based on the source material and install date values. So for this example, let's assume a utility knows all the cast iron pipes have been lined since the 1950s, and we can accurately deduce that these were cured in place. So in my expression, for any features where the material source field has a value of cast iron, and the install date is before 1950, then the liner method in the target field should get a value of cured in place. If the pipe material is not cast iron, the liner method will be set to other. And if the install date is not available, then the liner method will be set to unknown. Now, if I call this function in my workbook and execute the data load, I can review that this data was loaded according to the conditions in my function. So now let's talk about subtypes and how they come to play when loading data. Subtypes are a subset of features in a feature class or objects in a table that share the same attributes. They are used as a method to categorize your data. For example, if we take a look at the water distribution utility network data model provided with the Esri solution, I can see here that each one of my layers has a series of sublayers. The features for each of these subtypes can be categorized using a domain value specific to that subtype. If you're not familiar with subtypes, take some time to review the related documentation. So in my example here, I am loading data from a previous version of the water distribution utility network data model into a more recent version of the data model provided by Esri. Both these versions of the data model are using subtypes. So if I generate a data loading workspace from these source and target databases and enable the predictive field matching options so I can tap into some of the smart mapping capabilities provided by the tool, I will now get a series of workbooks matching these subtypes. These matches may not be perfect and may require some cleaning up. For example here, all of my feature classes have a subtype that is unknown. And the tool will match all of these given the fact that the description of the subtype value is similar. In most cases, this doesn't make sense, so I will remove these workbooks from the data reference sheet and from the related folders. So I will not go through all these workbooks today, but let's review some examples. In the source definition query column, I can see how the subtypes were matched based on the coded value for each asset group. The value in the asset group field defines which subtype a feature belongs to. For example, I define here that all source data with an asset group field value of 7 needs to be loaded into the target subtype service connection in the water device feature class. But you will notice the asset group 7 comes up 3 times here in the source definition query column. This is because the subtype 7 here is repeated across my data model, but within different datasets. So the asset groups we're referring to here are actually different. So if I look at the associated workbook for the loading of service connection features specifically, I can see in the Source Subtypes tab the subtype 7 for service connection. In the Target Subtypes sheet, I can see service connection is subtype 12 in the target data model. So in the mapping sheet here, the value 12 is hard-coded so that this value is directly written into the target asset group field when the data is loaded. The target subtypes and source subtype sheets help you quickly see how fields are being reused across the subtypes and which subtypes have different domains assigned for a field. For example here, the asset type field in this data model will always have different domains assigned, since these domains are being used to determine the different types of assets in a given subtype and their symbology. Once you've mapped your subtypes, you can review the mapping for the other fields, such as the domain field asset type. Similar subtypes will generally be matched automatically by the tool, but if your subtypes have very different descriptions, or need to be split up into different target subtypes, the easiest way to start mapping them is using the predefined mapping table when creating your data loading workspace. You can match the asset groups and asset types accordingly, and further split up data using definition queries in the data reference workbook. So let's take a quick look at an example where data from a source subtype needs to be split up into two different subtypes in the target data model. In a previous version of the water distribution data model, all meter features were stored under one subtype. But in the new data model, they are now separated into two subtypes, system meter and service meter. So let's see how the Create Data Loading Workspace tool managed this split. In the data reference sheet, I can see 3 workbooks were generated. The subtype code for the meter points in the source data model is 10. Now, one thing I need to verify. Should my meters be loaded into the meter station subtype in the water assembly feature class? Or is this an incorrect match? This appears to be an incorrect match, so let's remove this row and the associated workbook altogether. So now we're left with 2 workbooks, which are mapping the source meter subtype to 2 target subtypes, service meter and system meter. So how do I prevent my data from being duplicated? So basically having a full data load into these 2 targets. How do I split it up so that some of my meters go to the service meter and some of my meter go to the system meter? And how do I know which features from my source should be loaded into which target subtype? And how do I communicate this to this tool? So if you're familiar with your data models and the changes that need to occur, you should be able to determine which features will be loaded where. So in my example here, I know that all the meter points with the following asset type coded attribute values will be assigned to the service meter type, while the rest will be loaded as a system meter. If you're unsure how to type the expression in the source definition query column, here's a quick trick. In ArcGIS Pro, use the Select by Attributes tool to define your logic. This also makes it easier when you use coded value domains, since you can create your expression using the value descriptions, and the SQL generator will automatically provide the codes for you. So you can now copy this expression and paste it into the cell. So now let's run the Execute Data Load tool and see if my data is loaded as expected, with some of my features being assigned to the service meter asset group and their related asset types, and the rest being loaded into the system meter asset group. As we've just seen, when working with subtypes, you will first need to make sure the source subtype is pointing to the correct target subtype in the right target feature class. You will also need to verify if the source data should be split up into separate target subtypes, and then determine which attributes should define how the data is being split up. So this sums up what we had to cover for today. Get started now with the data loading tools and use inline expressions and external functions to further streamline some of your data transformation process. So this was our 4th video of our series on the data loading tools. Stay tuned for more. If you have any questions, visit the GeoNet community page for resources and updates. Thank you for watching.